Very good. I think we can start. We have left enough time to the guest to enter. So again, a warm welcome to everybody. Thank you very much for being here. Today is one of the many webinars that GMI is arranging. We started this procedure during COVID period, and since we had quite big success, we decided to continue it. We are providing several kinds of webinars. It is not a product presentation, it is a webinar on specific topics where we can claim to be expert. We are talking about intrinsic safety or EX protection in general, or functional safety. Normally, I'm working on the webinars with functional safety. Today, I have the pleasure to be here with Bob. So I'm trying, you don't see, but I'm trying to get control on the monitor, and I am not very, very successful. I'm sorry for that. I'm trying to change page. Yes, very good. So I want to give you some few details. Who's talking today? Myself, Mauro Perego. I'm Global Sales Director at GM International. Unfortunately, I have 30+ year experience in the automation, meaning that I'm not so young. But the main topic of today, which is hazardous location, will be handled by Bob. Bob is a friend of GMI since a long time, as well as deep expert on the matter. So I'll try to be short and to leave as soon as possible the speech to Bob so that we can go inside the topic of today. Just few words about GMI. I'm not going through too much in details because you will receive a copy of this presentation, but just to give you an idea of GMI, GMI is an Italian company dealing with and producing, manufacturing, engineering, field interface. Field interface that are normally used for DCS package, ESD package, fire and gas in various industrial sectors like oil and gas, chemical, petrochemical, pharmaceutical, food and beverage, and so on. We have 4 years experience. Sorry? No? Can you hear me? Okay, sorry. Yeah. We have 40 years experience, and yeah, we have production here in our facility near Milano. But of course, we are present worldwide with offices, with distributors. We have a total number of staff, which is around 200. And just to give you further numbers, we are, of course, 1,000+ installation worldwide. And since we like to share our knowledge, we are also executing different kind of training, covering the matter of functional safety, intrinsic safety, as well as cybersecurity. Again, we do everything here in Italy, and everything is fully tested before any components leave the factory. And since we are dealing with safety, whether either it is functional safety or intrinsic safety, we deal with the safety of people, environment. We put a lot of attention in our production, in our engineering on quality, and that's why finally we are so confident about the quality of the product that we provide standard 5 years warranty. Of course, being present worldwide, we have a lot of certification. We grant to our customer the possibility to use our equipment worldwide. So we have certification which allow us to deliver and to install in several countries like India, Korea, United States, Dubai, Abu Dhabi, and so on and so on. So many possibilities. Of course, we have a lot of further certificates to to cover the requirement of quality of our products. Let me try to change again page. Looks like the system is not happy. This is a slide just showing which are the solution that we provide. So we deliver intrinsic safe barrier, of course, safety relays, isolator, power supply system. We have multiplexer system which can be installed up to zone 1. We have a customized termination board when we go to connect our equipment to a specific manufacturer, DCS or ESD vendor. We have hard multiplexer solution, as well as surge protector and loop indicators. And of course, the last bullet is not a material, is not a component, but it is it shows our experience in intrinsic safety and functional safety, for which we are in the position to provide consultancies and training. This is just a short list of typical customers that we have. So we go through system vendor, EPC contractor, OEM, as well as, of course, end users. Before to leave the speech to Bob, I would like just to mention that anybody participating to this webinar will receive a copy of the PDF file. This webinar is going to be recorded and it will be immediately after it is concluded, it will be available on GMI YouTube channel. Further mentioning, if you are interested in topics like functional safety or intrinsic safety or hazardous location topics, or application of safety relays, you may go through the GMI website and find a list of webinar that we are going to arrange in the coming future. During this presentation, during this webinar, you have the chance to ask questions. So there is a specific button, question and answer. While Bob will go through the presentation, I will monitor and I will interrupt Bob in order to provide answer to your questions. And finally, at the end of this webinar, this presentation, we have a question and answer section. We collected questions from you while registering, or questions from the previous webinars. And we provide, and Bob is going to provide answer to that. So I promise to be short, and then now I have the big pleasure to leave the wording to Bob, which is going through now to the specific topic of today.
Well, thank you, Mauro. Appreciate it very much, and thank you very much for attending. Hopefully you can all see me and hear me and all that good stuff. This is the second time, or maybe, yeah, I think it's the second time we've done this webinar. And the first time we did it, we had a tremendous positive feedback. So we decided to go ahead and do this again. So there's a lot of good information. This is also based much upon my thought processes as far as, and from my experience, as far as which is the right concept. So this isn't necessarily the end all be all. This is coming from the experience. So Mauro, I'm getting a little bit of feedback. I don't know if that's me or you. Yes, hello.
I decided now I will switch off the so that most probably you should not have.
Yeah, there we go. And matter of fact, I am solo here in the office, and I think we had somebody dropping off something. So if I get interrupted from UPS or FedEx or something like that, I apologize ahead of time. So a little bit about explosive atmospheres. We've all seen this in some way, shape, or form. In order to have an explosion, either a dust explosion or a gas explosion, we have to have three things. We have to have, obviously, an explosive material, we have to have air or oxygen, and we have to have a source of ignition. So all of the various protection concepts, please come in. Sorry, we have to have three protection or three legs of this triangle in order to have an explosion. So all types of energy can be sources of ignition. So we typically, from an electrical standpoint, we think of electrical arcing and sparking, but there's actually a significant portion of various sources of ignition that we actually have to look at with regards to hazardous location equipment. So not just the electrical arcs, but it could be everything from electrostatics to impact, to exothermic reactions, to heating, all of these types of methodologies or issues that we find in industrial facilities. When we have a flammable gas or dust atmosphere, we have to take into consideration. So it's not just the electrical equipment, and it's not just the traditional arcing and sparking that we have to consider. So of the protection concepts that are out there, we break them down basically into four main categories. So intrinsic safety is considered to be energy limitation. We're limiting the amount of energy that can actually create a spark. So this is primarily great for all different kinds of instrumentation circuits and everything else. The first one, again, is energy limitation, which is intrinsic safety. The next one is non-sparking, and we commonly refer to this as the increased safety kind of concept, where we're basically making sure that there is no arcing or sparking inside of our electrical equipment. Containment is commonly referred to, or what we use as the main protection concept is flame proof, but there are some other containment concepts as well. But now we're containing, we're assuming we're going to have all three legs of the triangle, we're going to have an explosion, we're going to contain it. And then finally, separation, where we're separating the three legs of the triangle in some way, shape, or form. So pressurization is a good example where we're removing any flammable gas air mixture or combustible dust from our hazardous or from the equipment that potentially could create a source of ignition, if you will. For dust hazards, we basically have two main concepts: energy limitation, again, intrinsic safety, and then separation. We call it either dust ignition proof, pressurization, and others. All of these protection concepts are based upon and spelled out in detail in the 60079 standards. There's a bunch of different IEC 60079 standards. Within Europe, we commonly refer to these as the EN versions. In the United States, we actually have a UL version. In Australia, we have ASNZS. In most cases around the world, these 60079 standards are very much harmonized, and they're very similar. Not exact, but they are very similar in many cases to each country. So one of the important things is that as a user of EX equipment, we don't necessarily need to know all the details of what constitutes how to build a flame-proof enclosure, although we may have some people on this that are actually responsible for the design of EX equipment. So yes, you would need to know. But generally speaking, if I'm a design engineer and I'm trying to figure out what type of equipment or what protection techniques, I don't necessarily need to know all the nitty-gritty details of how to build an intrinsically safe barrier, but I do need to know how to apply intrinsic safety or how to apply flame-proof or some of these other protection techniques. So these are the various markings. We won't necessarily go through all of these in detail, but these are the relevant standards on the right-hand side in which you can find the details as to what constitutes that protection concept. So one thing you will actually see is that the markings have changed with a lot of this EX equipment over the last few years. Some of you may not be familiar with this, but historically, EXD equipment, flame-proof, is now known as DB. We've added these additional letters to the protection concept to tell us or to signify, if you will, what zone or category these can be used in. So for example, EXD, now known as EXDB, that was a protection concept that can be used in a category 2 atmosphere in the ATEX world, or a GB atmosphere in the IEC world, but basically it's telling us it's good for zone 1 and zone 2. So all these protection concepts are not necessarily suitable for all zones. Anything that you see an A at the end of it, that's going to be suitable for a zone 0 or a zone 20. Anything with a B at the end of it is going to be good for zone 1 and zone 2. Anything with a C at the end of it is only going to be good for zone 2 only. So energy limitation, how does this work? We limit the amount of energy below the minimum ignition energy for the particular gas group. We have 3 different types of intrinsic safety. There is what is called EXI-A, IB, and IC. Most of what you see from various manufacturers, such as GMI, are barriers that are rated for EXI-A. The differences between these products are based upon the fault tolerance. So it goes into the design of the IS barrier itself. For example, an EXI-A barrier will have actually 3 Zener diodes that are wired up in parallel. If you have a failure with one, we still have 2 other Zener diodes that can come on. An IB only has a single fault tolerance, meaning it only has 2 Zener diodes, where an EXI-C barrier will actually have only 1. It's not a fault tolerance. So the highest level of protection would be the EXI-A type barriers, associated apparatus. Now, non-sparking, again, we're eliminating the spark due to the design of the equipment. Typically, this is, we get away from using heavy cast flame-proof type enclosures. If we don't have any arcing or sparking, such as terminals, or maybe we have sealed devices, now we can place them inside of, say, for example, sheet metal enclosures. So generally, these are less expensive. They're obviously easier to work on. We don't have all the bolts. They're not as heavy. There's a lot of nice benefits for using EXE. And the trend is to try to use EXE instead of EXD in as many applications as we can possibly find. It does come, and it becomes extremely important when we're starting to select cable glands, because the cable gland selection for an EXD product is different than what we require for EXE, and it can be much more onerous. There's also what is called non-sparking, which is EXNA, and it's now known as EXEC, which was a lesser form of EXE. And just like EXD used to be known as EXD, it's now known as DB. The same thing holds true for EXE, which is now EB. So, first question, we didn't really cover this, but just to see if anybody is really paying attention today, we have a definition of a flashpoint. So what is the definition of a flashpoint? So we may give a minute or so. Mauro, do you know what the definition of a flashpoint is?
To be honest, I'm looking for your answer.
Well, it's not in the presentation. So
and I do not want to help the guest too much by telling you what is.
Right.
So let's give them some few minutes again, a few seconds again,
I think
until we reach.
Yeah, unfortunately, you can't vote. I think we have an issue with our Zoom thing, but if you see the answers there, because I think it shows the host and panelists cannot vote. Or is everybody able to vote on this? Let's see.
I see that the answer coming in, so I just need a few seconds again for the last one, and then I will stop the question and I will share yours.
Yeah, go ahead and share the information if you could.
Yes, here it is.
Okay. So most
Can you
of you
see
guessed,
that?
Yep, I can see it. Most of you guessed A, temperature in which a gas or vapor will spontaneously ignite. That's actually not the correct answer. That is actually called the ignition temperature of a gas. We call that also, you can use different terminologies, but basically the gas, the temperature in which it'll spontaneously ignite is considered to be the ignition temperature. So actually the correct answer here is is where the temperature in which a flammable liquid will turn into a flammable gas. So when we store, say, liquids at maybe liquefied natural gas, it's primarily made up of methane. And the flash point for liquefied natural gas is extremely cold. Well, at the moment when which starts to warm up and we all of a sudden start releasing flammable vapors, that's called the flash point. So flash point is always going to be below the ignition temperature of a gas. And it's important to understand, especially with area classification, because flammable liquids will not ignite. It's always the vapors that will ignite. Because the issue is with liquids, because liquid has no air, if you will, associated with it, in order to have an explosion, we have to have a combination of air in conjunction with the vapor, and that will ignite. So liquids, when they're stored, LNG tanks, for example, because they're stored at very, very cold temperatures, it's primarily a liquid, then it's actually very safe. The problem is that when we release LNG and it warms up and it gets into the atmosphere, now we have gas vapors. So that's when we have to take real concern about it. Okay, let's see if we can continue on. So some of the other EX protection concepts, as I mentioned, containment, there's flame-proof, powder-filled, and closed break. So these concepts contain the explosion and do not allow the hot flaming gases to ignite the surrounding atmosphere. So typically we take what you see on the right-hand side where we have a flame-proof product and we populate it with a bunch of arcing and sparking devices, maybe contactors, circuit breakers, relays, all different kinds of products. These can all be general purpose, and we put those on the inside of a cast flame-proof enclosure, and we'll have an explosion on the inside of this enclosure, but because the flanges act as a flame path, or the threads, those are all a flame path, it cools that hot flaming gas. So by the time it reaches the outside atmosphere, it's below the ignition temperature of the gas that is surrounding the enclosure. So the same thing holds true for powder filled or enclosed break. These operate in the same concept. Powder filled is a very fine quartz powder that we might encapsulate something with. And we actually do have a small explosion on the inside of these, but the quartz sand actually cools it off. And then we get into separation. And separation can be many different forms. Encapsulation, where we're actually sealing something with some sort of resin, hermetically sealed, pressurization, oil immersion, or restricted breathing. So these are all protection concepts that we can use to separate, if you will, the flammable gas air mixture from any heat producing or arcing devices. And it's not uncommon to see a lot of components that you'll find that are EX certified might incorporate these concepts. So for example, that ballast that you might see down on the lower right-hand corner, that's actually an encapsulated ballast. So we take an encapsulated ballast and we put that on the inside of a light fixture. So we don't have to worry about the ballast. Now we have to worry about the other components inside of a light fitting, such as lamp holders, the enclosure itself, the separation of terminals, and then we would come up with a product that might be EX, EB, MB, so forth and so on, and be suitable for zone 1. So we're combining protection concepts here. So what do we really need to know as far as what is the best concept for us, right? Well, it depends on which zone we're going into, obviously, right? If it's a zone 0, we're really limited to intrinsic safety, double fault tolerant, or encapsulation. Those are really the only two protection concepts that we can use in a zone 0. So we're very limited as far as what our selection criteria comes up to be. What are the gas groups? We have 3 different gas groups that we have to deal with: 2A, 2B, and 2C. 2C are the most onerous gas groups. They are the most violent. Things like acetylene and hydrogen are gases that fall under 2C. Well, if we're using flame-proof products, for example, there's a lot of limitations on the use of flame-proof products for 2C applications because the explosive pressures are too great and they will not be able to contain those gases explosions and cool them off in time. So we're limited somewhat for 2C applications. What's our temperature code? All gases and vapors will have what is called a temperature code, and all EX equipment will have temperature codes. Products that generate a lot of heat will be operating obviously very hot, and we have to be concerned with, is the ignition temperature of the gas going to be lower than the operating temperature T code of this particular piece of equipment? If we're talking about, say, instrumentation circuits or something of 4 to 20 milliamp circuit, generally these are low energy. The T codes are going to be very cool. We're not generating a tremendous amount of heat. However, if we're putting transformers or maybe high intensity discharge lighting into a hazardous location, these products will generate a tremendous amount of heat. And this is also going to be a limiting factor for us that we have to take into consideration. And then finally, what's the ambient temperature? Any piece of EX equipment, if it's not marked, is rated -20 to plus 40 degrees C. However, I know in many parts of the world, including here in the US, we have areas in which, up in the Gulf of Mexico, for example, we require a lot of our EX equipment to be rated at least plus 50 degrees C. So we have to make sure that whatever protection concept that we're using or the equipment that we're using is going to be suitable for either very cold temperatures or very high temperatures, especially if they fall outside of the standard range of EX equipment. And that also affects what concepts that we can use. So we have another poll question.
Yes.
The protection concept, intrinsic safety, constitutes what protection concept? So this one I did cover.
Let's wait. Do you still have echo from my PC or?
I think I do. I see the poll. So you should have a choice, either quenching or cooling, removing the explosive vapor from the relevant surface, limiting the amount of energy, or eliminating or reducing the heat or sparks in a hazardous area. And by the way, while we're doing this, we teach what is called, I'm an instructor for what is called the IECEX Certificate of Personnel Competency Program. And these questions are actually some of the questions that we have in some of the general courses, if you will. So these are the things that we would all need to know.
I think almost all have given an answer, so I stop the poll and I share the results so that you can comment.
Yeah, excellent. Vast majority of you got this right. It is limiting the amount of energy that can be released into a hazardous area. So again, we're concerned with making sure that if there's any fault condition, say using intrinsic safety, the purpose of the barrier is basically to make sure that we're limiting the amount of energy that can be released into a hazardous area under normal or fault conditions. So that's the function of an intrinsically safe barrier. So quenching or cooling, that's flame proof. Removing the explosive vapor from the relevant surfaces, this could be pressurization as an example, or eliminating and reducing the heat sparks in a hazardous area. That would be something like EXE or increased safety. So let's see if I can do this. So some generalities. There's a couple other things that we need to keep in mind. Intrinsic safety is power limiting. So realistically, we're limited to about 1 watt or less. So people sometimes ask, I want to go intrinsic safety for my lighting system. Well, we can't make a light fitting intrinsically safe. We might use some intrinsically safe components, but generally speaking, we cannot make light fittings intrinsically safe because there's not enough energy, right? Or we're limited on the amount of energy. So intrinsic safety is primarily a protection concept that we would use for control circuits, right? I mean, 4 to 20 milliamp control circuits, transmitters, solenoid valves, those types of products, intrinsic safety is very much in the ballpark for. Increased safety is not a gas group dependent, so we can use it in all gas groups. And generally, it's always going to be suitable for T codes of T5 or hotter. So we don't have limitations on either gas group, and generally we don't have limitations on T codes with regards to increased safety. Some of the other concepts, encapsulation, sand filled, they're generally at the component level. So they're built into the particular product. It might be a complete system that you're buying or specifying or using or what have you. And they're going to be built into a lot of these other products that might have an overall certification. The benefit of flame-proof and pressurization certainly allows the use of non-EX equipment to be used in a hazardous area. So sometimes this is a simple solution where maybe we just cannot find an EX rated whatever. So if we populate it inside of a flame-proof enclosure or pressurized enclosure, this certainly allows us to go that route. The legacy EXN products are limited to zone 2 areas only. So again, we're limited there, as I mentioned. Anything that will have a C at the end of the first letter is now suitable and is only suitable for zone 2. So those are some generalities. Oop. So some of the advantages and disadvantages of all these protection concepts, right? So one of the advantages of flame-proof, it's easy to apply. We can take a lot of general purpose equipment, we can put it in there. We can make almost any electrical component suitable. It is very robust construction. It can be cost effective depending on the product involved, and it is fairly easy to combine with other techniques. For example, on the right-hand side, you actually see a combination EXE enclosure nippled together with an EXD enclosure. So they're taking all the arcing components, putting in a flame-proof box. Maybe they put the non-arcing components inside of an EXE box, and all your cable terminations are coming into the EXE enclosure. So flame-proof's been around for many, many years, widely used, certainly has got some advantages. However, there are some big disadvantages with flame-proof. As you can see over on the right-hand side, if we don't tighten down all the bolts or we're missing bolts, that's a major issue. We've now lost our protection. Painting of the flame-proof joints, right? Maintenance on EXD equipment. It usually is not something that comes from the factory like that, but once it gets out into the field, maintenance people don't understand. They start painting the joints, and then all of a sudden we've lost that protection. Corrosion resistance. Certain cast materials are not very good for certain corrosive environments. Obviously, scratches in a flame-proof joint is a big issue. There's also a requirement for an obstacle of 20 to 40 millimeters from a flame-proof flat joint. So we have to keep a distance away from that flame-proof joint to allow that pressure to escape. If we don't use the right cable gland or stopping plugs, and we don't install it correctly, that's a big issue. And again, improperly installed cable glands. One of the biggest issues is it's heavy and it is difficult to service. We have a lot of bolts. We don't want to open up all those bolts every time. So sometimes people will just put a bolt in each corner and they think they're good to go. The other thing is making changes to the contents of the EXD box. This is one thing that people don't think about, but if we actually rearrange the contents inside of an EXD box, we can actually change the characteristics of the explosion that could take place on the inside of the box and create what is called pressure piling. So we have to be very careful as far as the arrangement of all the equipment on the inside of a D box. And then finally, a U component certificate. What this is anything that you see a U component on means that it's an empty enclosure. The IEC standards, the EN standards all state very clearly that you cannot use a U component certified product as part of your final assembly. It has to be a fully assembly certified product. So this is a big issue where people just buy empty enclosures, put a lot of stuff in it, and they think they're good to go. You cannot do that. So some of the advantage of increased safety, it's lightweight. We have, in many cases, the materials that we can use are better from a corrosion resistance standpoint, things like stainless steel or glass reinforced polyester. It isn't gas group dependent. We have lower T codes generally. It's easier for your cable gland installation, and generally it's lower cost depending on the product and the application. There are some issues with increased safety. Missing bolts. Now, in this case, the missing bolt just means that we're going to allow more water to get on the inside of the enclosure. It's not necessarily going to affect its EX suitability like a flame-proof product. It's an issue, but there's fewer bolts. Damaged enclosures or seals. So our IP ratings are no longer guaranteed. Improperly installed seals, or it should be really improperly installed cable glands, but bolts tightened with the wrong torque. We use the wrong blind plugs and cable glands, incorrect mounted of cable glands, making changes to the content of the EXE box. We add terminals or non-EX components. And again, that U component certificate. The downside on EXE is we can't use just general components on the inside of this enclosure. All of those components on the inside, including the terminals, must have its own certification. So if we cannot find certified products to be able to populate on the inside of this enclosure, then this concept really doesn't work. The good thing is that so many products now, you can find EX rated PLCs, EX rated switches, relays, contactors. You can find a lot of that. We can put all those types of components on the inside of sheet metal or plastic enclosures. So what's an advantage of pressurization? So we can use enclosures that are more similar to industrial panels. Basically, we can take pretty much an industrial panel with some variations, and we can make that pressurized. So again, like flame-proof, we can use general purpose equipment. It's also not gas group dependent. We can incorporate cooling features for high ambient applications. It's very well suited for things such as PLCs, HMIs, and similar type equipment. And we can actually pressurize an entire building. And this is not uncommon. And we call this EXPV. And so pressurization is a great concept, and it works very, very well. However, some of the things that are problems. In the enclosure itself, we don't have very good sealing, which allows air to escape freely. It does require monitoring via an alarm and may involve automatic shutoff of the equipment. So if we have a critical piece of an EX equipment and we lose positive pressure, this may or may not be a good protection concept. Now, what we can do for those applications, we can actually use redundant air systems. So we might have to do a little bit more engineering on it in case this is a critical piece of equipment. The quality of the air is important. If we are pumping in bad air with a lot of contaminants, then that starts to damage the inside. And is air available, right? Not all facilities have instrument air or some sort of clean air available that they can draw inside of these enclosures. And again, adding components after certification. But again, pressurization is a great technique, great concept. So some advantage, and this should actually say intrinsic safety, I think, instead of increased safety. So what's the big advantage of intrinsic safety? When selected properly, it is the safest EX protection concept. There is no doubt, because if it is selected properly, you will never have a fault condition in a hazardous area. And again, it allows the use of non-EX certified equipment within the most onerous zones of use. For example, if we have a simple device, such as a proximity switch, we can use an intrinsically safe barrier with that proximity switch that we can buy off the shelf, a non-EX simple device, and we can use that in a zone 0 area. So it allows the use of non-certified equipment in some cases. It can be extremely cost effective. It is truly the best solution for low voltage instrumentation circuits. Little maintenance is involved. However, There are some downsides of intrinsic safety, right? It does involve some engineering to match the associated apparatus to the device. We can't just take any barrier and any device and say we match them together and we go. We are definitely limited to the energy of the MIE of the gas group. Barriers can be defeated and bypassed. We can, like any EX protection concept, these can actually be bypassed. The issue is on intrinsic safety is that if a barrier happens to have a fault condition and a fuse gets blown, well, now all of a sudden I have no protection. And of course, if this is going to a critical circuit and I don't have a replacement barrier handy, people might actually just take a pair of cables and jumper over the barrier. And I've seen this happen from inspections. And now all of a sudden we have no protection. For Zener barriers, it requires a clean earth, separate from our normal dirty earth that we use in facilities. And this is a real pain in the rear end for using Zener barriers. Now, GMI doesn't offer any Zener barriers, but there are quite a few manufacturers that do provide Zener barriers. And there are strict requirements for wiring and segregation between IS and non-IS circuits. So, for example, what you see in that panel on the right-hand side, we have to maintain a 50 mil separation between all our IS and non-IS circuits. And obviously, in this case, that has not been achieved. So some of the deciding factors, again, going into zone 0, IS is the protection concept of choice. For zone 1, if a component exists that has EX certification, it may be more beneficial to consider multiple protection concepts going EXE. If EX components are not available, it makes sense to either consider EXD or EXP. If air is not available, then EXD seems to make the best sense. What is also the quality of my installers? Certain protection concepts rely on a higher level of competency versus others. When we do use EXD, we do require a higher level of competency because now we may have to install barrier glands versus non-barrier glands. And we have to select the right components for that. So there's a little bit higher level of requirements that we do depending on the installer's background, skill set, and this is where an area where a lot of problems do lie is the selection of cable glands for EXD enclosures. So we want to make sure that we get that right. So you'll see on this one, this is an interesting slide. Well, on the one on the left, you see again that combination of flame-proof and increased safety. But what you see over on the right-hand side, this is an example from a manufacturer that's actually providing you 3 different protection concepts and allows you to install it in 3 different methods. So the first marking string, you're seeing it, you can install it as an EXD product. There's your ambient ratings, there's your T codes. On the bottom left hand, I can install this product using an intrinsically safe barrier. Or on the bottom right, I can install this as what is called an EXNA non-arcing type product. So many manufacturers are actually putting it on their labels that you can install it in a different fashion. Now, this is great from a manufacturing standpoint. It's also great from a selection standpoint. But where the issue comes into play is that when I go in to inspect something, and I need to know as the inspector, how did you install this? Which protection concept did you use? If you did intrinsically safe, then I want to see my associated apparatus. I want to see my barrier. I want to see your control drawing or your descriptive system document. If I'm doing it as EXD, then I'm going to be looking closely at the cable gland and the cables that we're using. So there's positives and negatives with these different protection concepts from an installation standpoint that we need to know. The good thing is, again, manufacturers are providing you that flexibility in many cases with a single product that can be installed in many different ways. As I mentioned, usually a lot of issues come down to the use of cable glands. So what you see there are just some pictures of various cable gland issues. The barrier glands are not properly poured. On the right-hand side, we have a flame-proof product, but yet we have a nylon EXE cable gland. We have a gland down on the bottom right-hand side, which obviously we've had some heating up on the insulation on the jacket. And in the middle, you see that the person has actually used some sort of tape on the threads, which is not allowed. And down on the bottom left, you see actually, because the cable gland didn't fit the cable, they put some sort of electrical tape, which is a big no-no as well. So cable glands, even though it's not really protection concept driven, I mean, it can be certainly, but a lot of issues that we see from an inspection standpoint are specifically derived from issues of people doing installations. So just to summarize, I didn't tell you necessarily which is the best for you, right? But there are some generalities. They do exist, and you can kind of see, okay, which protection concepts has pros and cons. The material costs are only one factor to consider, right? Installation cost, the cost of glands, the cost of maintenance, all of those types of things we do need to take into consideration. And again, the installed cost, ease of maintenance, the skill set of operators, availability of replacement components, and the support from the manufacturer are all key and critical. Here's the way that I look at things when people ask me. I don't necessarily come into an application thinking that this is the only way forward. We supply a lot of EX equipment, and a lot of people will come to us and ask, hey, we've got this application, what would you do? And I like to provide options, you know, to say, hey, look, if you want to do it this way, this is how you could do it. Or if you want to do it this way, this is how you would do it. It may involve different products. These are the advantages, disadvantages. But again, keep that in mind, because in many cases, a lot of times people just assume this is the only way we have to go, and there is not really an alternative out there. But sometimes if you kind of keep an open mind, you can find that there is actually a solution out there that maybe wasn't necessarily thought of up front. And I think this is our last poll question, then we'll do our Q&As.
Yes, this is the last one.
So yeah, the U at the end of an EX certificate, what does this actually mean? And as I mentioned, we do a lot of inspections. I did an inspection for a customer up in Canada a couple of weeks ago, and I saw this, and this was a major issue. And anytime that we see a U at the end of a certificate, what does it mean? So maybe we'll give that a minute or so, a couple seconds.
Few seconds again, those are coming in.
This is one thing I do want, if you have not seen this before, if you're not familiar with this, if there's anything to take away from this webinar, take this away. Besides that, Mauro's just a handsome man.
Okay, so let's stop it here.
Okay.
And let's share the result.
Yep. Okay. So most of you got the right answer. The equipment has a component certification only. Some of you said conditions for safe use. Well, there is another letter that you will find at the end of certificates, and that is called an X. And an X condition is conditions for safe use. When you see a U at the end of a product, as a final product, say I'm looking at an enclosure and I walk up to it and I see a U at the end of it, immediately that is a no-go. It is very clearly stated in all these relevant installation standards that you cannot use a U certified product without further evaluation, meaning I'd have to go back and have a third party come in and certify the complete assembly. So this is something that I know has jumped up and bit people all over the world on. We see it all the time. If I'm a design engineer, I just want to make sure that I don't select an enclosure that has only a U. Where this comes into play is that if I buy an empty enclosure without any components, either EXE, EXD, EXP, and I go ahead and just do it myself, right? The manufacturer will be happy to supply you with that U component box, but they don't know, the manufacturer hasn't made an evaluation as to what you're putting in the box, and therefore it will not have a T code. And it is a requirement to have a temperature code on your product. So you will absolutely need to do a temperature rise test, and you will probably have to do some additional testing, and it will need to be basically recertified. So don't make that mistake. So many design engineers, they just select equipment and it has a U at the end of it. Don't do that. You'll find a lot of components will have U's. That's okay because they're certified as part of an overall system, but not the boxes. We do have a SIL wall chart that we will get you if you would like, and we also have an EX wall chart. I'm not sure if we have that here. Now, let me finish this.
Yes, just to mention that this is confirming our expertise. So we have these two wall chart, and we have them available in paper as well as in electronic format. So you just drop us an email, and we can provide you if you need that.
Yeah, I was going to pull up. No, I can't find it.
I do that. I do that.
You've got it?
Can you see?
Yes, I see it.
Okay, so now we have the last section of this webinar. Is the we already, as mentioned before, some questions. And now Bob is going through this question and answering that. So
Okay.
if I'm really able to get control, here I am not able to control. I think it is better you read the question.
Yeah, so we had a question on using an EXEB enclosure with an EXD sensor in a zone 1 environment. Can this be done? And the answer is yes. I don't know if I can scroll or you can. Yeah. So what we're doing here, we're not actually combining the protection concepts together in one product. So we're using maybe an EXE enclosure in conjunction with an EXD product, if you will. So an EXE box involves the use of EXEB terminals and possibly some other EX components. And then we would wire that up to our EXDB sensor versus a junction box. Again, the wiring methods, what we would do, we use, the important thing to remember with regards to wiring methods is that we need to use a cable gland that's suitable for the protection concept of the enclosure. So for example, on the EXE box, we would use an EXE gland. For the EXD sensor, we want to make sure that we use an EXD gland. So there are glands that will have both ratings, so we can use one gland for both, but we have to make sure that we match the protection concept with the cable gland that we use. Okay. This came up, which is the best glands to consider for EX application, and do we always need to use barrier glands with EXD enclosures? This is not a sales pitch, okay? But if you go to the next slide, we do sell Hawk cable glands, but there are many good brands out there. Hawk is one of the better ones out there. But what I look for when I'm looking at cable glands, I want to try to find a cable gland that's easy to install. Ideally, I can use it on as many cables as possible, and it also covers as many of the protection concepts as possible. So the products that you see down below on the left-hand side, that's a gland that's EXD, EXE, EXT for dust, as well as EXNR. And it's for use with all armored type cables. The cable gland on the right-hand side is the exact same, except it's a barrier gland as opposed to a non-barrier gland. And in some cases, depending on the cable application, we might have to go with a barrier gland versus the gland on the right. But basically, both of those glands can be used for, about 100% of the application, one or the other. So On the other hand, you can go with a dedicated EXE gland. And if I have unarmored cable, it's going to be a lot less expensive. So it really just depends on what your application is, how many glands you need to use, how skilled your technicians are as far as doing the installation, as far as cable gland selection. Yeah, mechanical protection concepts. This is starting to come up. So what are the relevant standards and where does this apply? So we go to the next slide. So I mentioned to you that the other standards we follow are the 60079 standards. Well, now we have a joint ISO IEC 80079 standards. In Europe, these used to be known as the EN 136. I can't remember the 5 digits, but it started 13. And now it has been introduced or reintroduced as ISO IEC and now EN 80079-36. So what we're looking at now is mechanical equipment for use in hazardous locations. And again, those are some of the ignition sources, some of the same ignition sources that we look at from an electrical standpoint, but now we're looking at mechanical equipment. So there's 2 main standards. The 36 covers the fundamentals, while the 37 standard covers the various remediation concepts. So there's a bunch of information in these standards, and we go into details in the training programs that we offer and how to build ignition hazard assessments and what this is all about. Next slide. I think we went backwards. Or maybe.
I'm trying to go ahead.
Or maybe we duplicated our sets. I think it's the same. Yeah.
Okay, maybe now it is better.
Yeah. So what are the main differences between US-Canada requirements for EX versus the rest of the world? So we are different. The US is a little bit more different. Canada is a lot more similar to what the rest of the world does. So if you could kind of go into the next slide there, Mauro, just hopefully explain this real quickly. So the US and Canada, we both have our own electrical codes of practices. In the US, we call it the NEC. We call it the National Electric Code, but officially it's called NFPA 70. That's our electrical standard that we follow. In certain parts of the United States, offshore, we follow API recommended practices, or we might find relevant details in either Coast Guard or BSEE for Code of Federal Regulations. But we have adopted the 60079 set of standards with variations. Excuse me. In the US, the UL versions of 60079 standards include general purpose requirements for shock and fire hazards, which are not covered within the IEC standards. Canada has adopted the zone concept, but does require approval by a Canadian testing authority to the relevant Canadian CSA 60079 standards. So in the US, we still have the legacy division concept, but we have adopted the zone concept. So now clients here can go either class division or to the zone concept. In Canada, they've discontinued the use of the division concept and gone strictly to the zone concept. The important thing to note here is that products for both Canada and the United States require testing to either in the US, a nationally recognized test lab. In Canada, it has to be approved by a Canadian lab. So we cannot just take, for example, ATEX equipment or IEC-EX equipment and just use them in general. There are some exceptions to that. For example, in the US, in territorial waters, the US Coast Guard has adopted IEC-EX to allow people to use IEC-EX equipment in the Gulf of Mexico. But generally speaking, anything onshore would have to be approved by a US testing lab and be certified by that, even that the product standards are very, very similar to the IEC standards. We spent a whole day going over this whole topic with a customer here not too long ago, because it can get very difficult. Can I install? Yeah. Can I install an intrinsically safe barrier in a Zone 2 environment? Yes. Yes, you can. You can actually install them into a Zone 1 environment as well. So a lot of barriers now are actually rated for installation in a Zone 2. However, if I had an application where I actually needed to install it in a Zone 1, then what I would have to do is install it inside of a flame-proof enclosure or possibly a pressurized enclosure. So these would be my options if I actually needed to install intrinsically safe barriers into hazardous locations. But in many cases, intrinsically safe barriers, as I mentioned, are rated for Zone 2 installation, and they can be installed in that case in generally a sheet metal enclosure. So you do have some options there.
So we go to the last question, last technical question, if I'm able to jump. I'm realizing I'm having some internet issues. Okay.
So how to select a device suitable to be used in a particular area. So I've got a Zone 2 area, 2A and 2B T3 requirement. So if we go to the slide, we'll go through this real briefly. So here's a slide of a label on a particular product. So what's telling us it's suitable for Zone 1 or Zone 2? If we notice on this, we have what is called category, 2G. So that's ATEX category 2G is basically telling us it's suitable for Zone 1. You see a GB at the end of it, and that's also telling us it's good for Zone 1 and Zone 2. In this case, the client said, hey, I need a 2A and 2B rating. Well, in this case, the manufacturer has a 2B plus H2. So that means that this product is suitable for 2A and 2B plus hydrogen. So it would be suitable for that application. They required a T3 rating. So a T5 is actually operates much cooler. So therefore, this is fine from a temperature code standpoint. The ambient for this project required -20 to +50 degrees C. We notice the T ambient on this is -20 to +55. So the product is suitable for installation in that. The certification, we don't know what the client needs, but it is certified under ATEX as well as IEC-EX. And then finally, our IP rating, it shows on there, it's rated for IP66. So it's important to understand all the labelings, and we've done some webinars on just understanding labels. And I would invite you to go check those out because we have a lot of different examples of different EX labels to kind of understand how to decipher all this information.
But before to go to the next slide, there is a question that I would like you to go through and to answer, Bob.
Sure.
The question is, can I install EU certified box with all AX certified component in it in Zone 1?
No, not an EU certified box. It cannot be done. It's not allowed. Even though the box is EX certified as a component and all the components on the inside are EX certified, it's not certified as an assembly. And the -14 standard does not allow you to do that. So you would have to get it assembly certified. Now there's a way of doing that. There's actually either under ATEX or IEC-EX. You can actually do it after you've built the equipment. And if you're only doing, say, a one-off or maybe building 5, there's what is called unit verification, which can be done. So it can be actually done in the field, and it can be done actually after the equipment has been installed. So it is something that can be accomplished. You don't necessarily have to tear it all out and start over, but don't do it. Don't do it.
Very good. Okay, this is not really a question, but it gave me the chance to remind what I mentioned in the beginning of the webinar. We have a lot of other live webinars, so my invitation is to go through our website to check out which are the topics that we are touching. As mentioned, we are touching several topics about Azzardo's location, together with Bob. We have other friends dealing with us about functional safety. We have also a webinar about specific applications. So you just go through our website and I'm sure you will find further topics that you will be interested in. Okay, there is another question, but it is not really a question. It was a thanks to your answer. Yes, again, not only webinars, so not only live webinars, we are recording all our webinars. So if you go through our YouTube channel, you have the chance to go through previous webinars, so you can also select different topics. This is an alternative to, or in addition to the possibility to be together with us. Very last question, I think before to launch this last poll, I take the opportunity to thank you very much, Bob, for the very formative section that you gave us today. I look forward for further topics together with you. And I take also the chance to thank all the participants. I have to say that whoever joined us in the beginning was with us up to the end, which is in somehow a sign that the performance was between excellent and good. And in fact, after most of you or all of you have answered, I'm proud to share your feedback, which is ranging from good to excellent. So again, you will receive this presentation. You will see our email address. Anything that you would like to ask us in coming days, we are here. Again, thank you very much. Enjoy your day. I think, what time is it there, Bob?
Yeah, it's 11:10. So
11:10. So you still have a lot of time to go. I'm just adjusting my papers before to think my dinner.
There you go.
Check what my wife prepared for me. So again, thank you very much to all, and look forward to meet you again. Thank you, Bob.
Thank you. Thank you, everybody.